Hello everybody. In this video I'm going to um, finish up our discussion on Earth's Earth system, and in this video I will be talking about the rest of the spheres that I mentioned in the previous videos, which are Hydrosphere, and then we're going to be talking about Cryosphere as well, and last but not least we're going to be briefly talking about Biosphere at the end. Okay, so let's go ahead and start with the hydrosphere. The hydrosphere right here, the hydrosphere refers to water on the Earth's surface and underground as well. And the Earth is considered as the water planet because we have water covering about 71% of the Earth's surface. Okay, and the Earth is also considered as a unique planet because water exists in this planet in all three phases. Okay, we have the solid phase, and we're going to be talking about that in a minute. And then we also have the liquid phase, right? The water, the liquid water that flows in the river, or we have it in the ocean, and as well as lakes. And we already talked about water vapor in the atmosphere, right? This is something that I talked about in previous video. So the origin of Earth's hydrosphere, this ties very strongly with the processes that I already explained in previous video, which is called the volcanic outgassing that happened in the early Earths. Okay, and one of the gases that was released by volcanic outgassing is H2O, right? So what happened here is that when water vapor in the atmosphere condense and it falls down as rains, and it remain liquid on the Earth's surface. Okay, now how do we know about this? Again, because of the rock records that we have on Earth. The oldest known marine rocks has about 3.8 billion years old. That means that at least 3.8 billion years ago there was already ocean forming on the surface of the Earth. These are the different hydrospheres reservoirs that we have on Earth. The ocean is the largest reservoir for the Earth's hydrosphere. Takes up about 97% of the entire hydrosphere of the Earth. But most fresh water, the ocean has salt water, right? So most fresh water is frozen in glaciers. Okay, glaciers are something that we're going to be talking about in a minute when we talk about cryosphere. We also have groundwater as about 30% of the fresh water, and there's only about 1% in lakes, rivers, and streams. Okay, so this is the illustration. 97% is in the ocean, and then we also have about 2.8% of fresh water, and fresh water is found in ice, groundwater, as well as surface water such as in lakes, rivers, or streams. Well, the ocean, there will be a module designated for the oceans later on, but here I would like to just briefly talk about it, that the ocean is a continuous body of water. Again, it covers about 71% of the Earth's surface, and the ocean, believe it or not, is stratified, meaning that it has layers. Okay, so it has upper layer and lower layer. Okay, in the upper layer, it is mostly driven by the temperature, as well as the winds that cause the currents to form in the upper layer of the oceans. And how about the lower layer? The lower layer, the solar radiation has little effect because the sunlight cannot penetrate deep enough into the deeper parts of the ocean. But salinity and temperature plays such an important role in the deeper parts of the ocean. Okay, salinity and temperature. Okay, these two are important in the deeper parts of the layer of the ocean. If you don't know what salinity, go ahead and Google it. But salinity is basically the amount of salt or the concentration of the salt or other types of ions within the ocean water. All right, so this is the surface currents redistribute the heat, as you can see here. These arrows, these different arrows represent the surface current. As you can see, most of them are pretty hot, and because of this red color right here, um, but some of them are pretty cold as well, especially the ones that are coming from the northern part of the Earth or in the southern part of the Earth at the bottom part of this picture. Okay. The ocean current would create something that we call as the deep ocean conveyor belt. The deep currents are in motion due to differences in salinity and temperature. Okay, the denser water will sink to the bottom. Okay, because it is colder and saltier, and it flows through deep ocean and back to surface. As you can imagine here, we have this warm deep current right here, flows over the Indian Ocean and the southern ocean of the southern part of the Atlantic Ocean, and it goes up and it goes down where the deep water formation occur here in this region. The reason for that is because these deep current will become colder as it travels up to the north, and this cold water will eventually sink to the bottom, creating these blue arrows that represents the deep ocean current, the deep and cold ocean current. Okay. The next part that I would like to talk about is the cryosphere. Cryosphere is the frozen water, or the water molecule in solid phase that are found on the Earth's surface, and ice covers at about 10% of the Earth's surface, and most of these ice are found in Greenland and Antarctica. Okay, so here are the stuff that are considered parts of the cryosphere, such as the ice sheets, okay, or glaciers, okay, ice that are preserved on land, okay, or we also have some iceberg, ice shelf, sea ice, or some frozen water in the lake or river ice. Okay, glaciers and ice sheets. Glaciers exist at high elevation in mountains, okay, or in high altitudes near south and north poles. Okay, so what are glaciers anyway? Glaciers are a body of ice that are preserved on land. Okay, so it has to sit on land in order to be called glaciers. Okay, glaciers form because snow accumulation is greater than the melting of snow, and that condition would allow glaciers to develop. Okay. Again, of course, when you think about glaciers, you got to think about some cold regions, and these cold regions, of course, are found in the south and northern polar regions of the Earth. Okay, but not only that, glaciers can also be found in high elevations, such as here. Here is the equatorial region right here. This place right here represents the equatorial regions, and yet we still have glaciers on top of that mountains, such as the one that we found, for example, in Himalayan mountains, right? We also have glaciers in there, even though it is not located in the North or South Pole, because as you go upward, as we discussed in the atmosphere in the previous video when we learned about atmosphere, that as you go upward in the troposphere, the temperature will become colder and colder. Okay, and that would allow glaciers to be preserved in the high elevation. Okay, such as in high mountains. So, for example, these are mountain or alpine glaciers, okay, in the high altitude. And when we learn about glaciers, there's a lot of sad stories about glaciers because they are disappearing. Okay, as you can see here, 1938. These are Glacier National Park right there. As you can see here, in 1938 we still have plenty of ice, and 1981, look at this, there's no more ice over there, and the ice is shrinking, is constantly shrinking as we speak, throughout the recent history of the Earth. This is another sad story from Patterson glaciers in Alaska. This is what it looks like in 1920. Look at that. Ice is everywhere. But what happened here is in 2005, there's very, very little body of ice. Maybe we can only find ice over here, right there, or maybe right at the higher elevation right there. So it's a very, very sad story. Now, think about what causes the ice in glaciers or glaciers to shrink. Okay, what causes it? This is something that we're going to discuss when we learn about climate change later on. But here is another example of melting of glaciers in Greenland, for example. Okay, so this is Greenland right here. We have an ice sheet sitting right on that land right there, and Greenland Greenland ice volume is also shrinking, as illustrated by this model right here on the right side of your screen. Okay, so it contains enough water to raise sea level 7 meters if melted. So there's a very serious things and problems that are occurring right now in on Earth, and this is something that you all need to know. Okay, Greenland is melting. This is the discharge from many major Greenland ice streams. This is from Professor Conrad Steffen from University of Colorado right here. This is beautiful images looking at the Greenland ice shelf right here that is broken apart, as you can see here. Okay, so in terms of volume, it is decreasing, and it is very concerning. Okay, this is what happened in East and West Antarctica, for example. And Antarctica is the biggest, is the largest glaciers that we have on Earth. Okay, 2 of 3 large ice sheets on Earth are present here in Antarctica. Okay, and West Antarctica is much smaller and more susceptible to melting, which is over here on the in the western part. And if it melted, then you know what? It would raise sea level by 5 meters. Okay. So if you had some property along the shore, that's not going to survive with 5 meter increase of sea level. But anyway, contributing to current sea level rise by 2100 may contribute to 0.5 meter of sea level rise by 2100. That's what happened if it melted, if it keeps melting. Okay, and how about the East Antarctica? East Antarctica is very, very large ice sheet right here, and if it melted, then it would raise sea level by 53 meters. Such a ridiculous number right there. Okay, so that is we're going to be talking about ice sheets and glaciers later on when we learn about climate change as well. But those are some sad stories about glaciers, and it is true, and it is happening right now, and you should know about it. And the very last spheres of the Earth system is called the Biosphere, and I'm not going to talk much about this. Okay, all living organisms that inhabit Earth, that would be part of the Biosphere. Okay, all the vegetations, the animals, as well as us as well, humans. Okay, but there's definitely lots of interactions between Biosphere and the lithosphere and the atmosphere, as well as other types of elements in the Earth system. Okay, again, Biosphere consists of all life on Earth, from molecular level to vast complex ecosystem of the Earth's biosphere. And it is important because it produces food, and it has such an important role in carbon cycle. Okay, and it does filter pollution as well, and it captures energy and helps in soil development as well. Okay, so I think those are the things that I would like to talk about in this video, and I think I will meet you, and I'll see you again in the next video in other modules, I believe. All right, see you later. Bye bye.